A prototype is an early release of a product built to test a concept or process or to act as a thing to be replicated or learned from. A prototype is designed to test and trial a new design to enhance precision by system analysts and users. Prototyping serves to provide specifications for a real working system by finding problems early and testing the cohesiveness of the classes. Incomplete components can be simulated by having them return a fixed value to avoid random behavior which is difficult to reproduce. The waterfall software model never revisits a stage once that stage is complete. Once each stage is finished, the project passes to the next stage and continues until it is delivered. The benefits of this model are that time spent early in the software production cycle can lead to greater economy at later stages. A bug found in the early stages, such as requirement specification or design, is cheaper in money, effort, and time to fix than the same bug found later on in the process. Negatives of this model are that clients may not know exactly what requirements they need before reviewing a working prototype and commenting on it. They may change their requirements constantly. Designers and programmers may have little control over this. If clients change their requirements after the design is finalized, the design must be modified to accommodate the new requirements. This effectively means invalidating a good deal of working hours, which means increased cost. Iterative development. The basic idea behind this method is to develop a system through repeated cycles and in smaller portions at a time, allowing software developers to take advantage of what was learned during development of earlier parts or versions of the system. Learning comes from both the development and use of the system, where possible key steps in the process start with a simple implementation of a subset of the software requirements and iteratively enhance the evolving versions until the full system is implemented. At each iteration, design modifications are made and new functional capabilities are added. A design pattern is a general reusable solution to a commonly occurring problem within a given context in software design. Object-oriented design patterns typically show relationships and interactions between classes or objects without specifying the final application classes or objects that are involved. It is a description or template for how to solve a problem that can be used in many different situations. Design patterns are composed of several sections. Of particular interest are the structure, participants, and collaboration sections. Design patterns provide general solutions documented in a format that does not require specifics tied to a particular problem. Application analysis and design has many facets, some of which were discussed in this lesson. Class collaborations and object interactions must be identified, and CRC analysis is a good tool to use for this. The iterative approach to design analysis and implementation can be more beneficial than the waterfall model in regard to systems that will grow and evolve over time. Long gone is the software system that is written for one task and one task only. Often programming projects will be worked on by a team. You should design your classes in a way to facilitate collaboration with others. You should document your classes and methods within the code. You should design flexible, extendable class structures that make it easy for fellow developers to integrate your objects into their solutions or to connect to your system when they need to. And most importantly, always learn from your own and others' experiences. More often than not, someone has already encountered the issue you have and may have the answer, or perhaps just a new perspective.